Hey guys, so today we're going to be graphing systems of inequalities, which means you're going to be graphing two inequalities. So what I recommend for these notes is have two separate colors just so you can distinguish between the two of them and looking at the shading and stuff. So for example 1, we have two inequalities. We're just graphing them on the grid on the side right here, and I'm actually going to do this so you guys can see it a little bit more. I know the graph is a little bit smaller. And then you're going to state two solutions. Remember, for solutions, they can be a little bit different than what I pick. So let's look at that first one, and we have y is less than or equal to 2x. We have less than or equal to, so I'm going to draw a solid line just as a reminder for me. And we graph this the same way. We start with the y-intercept, which would be 0. And it is positive, so you're going to go up 2 over 1. 2 over 1 up 2 over 1. Sorry guys, this is a little bit small. Okay, I'm going to plot 3 points, and then I'm going to take a separate sheet of paper. You guys probably have a ruler, and then you're going to connect those dots. Okay, make sure you get all of them in there. Sorry, my paper is not cooperating. There we go. Solid line, solid line. Now it is less than or equal to, which means we're going to shade below, and I'm going to do that now, and I'm going to kind of keep it like this because we do have another one to plot. And what I also like to do is I like to put the color next to it with a little bit of a dot so you guys can see, like, hey, this one's pink, this one's whatever color. Now let's look at our second one. We have y is greater than or equal to, and I'm going to put that dot to say, like, this one's blue, negative 3x plus 2. Now we're going to plot this the same way. We're going to start with the y-intercept, which is 2. My slope is negative 3, so I'm going to go down 1, 2, 3 over 1. Okay. It is solid, which I forgot to write. And then I'm actually going to go backwards, and I'm going to do, actually, no, let's just go down 1, 2, 3 over 1, which would be here. It is a solid line because it's or equal to, so we're just going to connect those points. Okay. Connecting points. Now if I look at this, it says greater than, so I'm going to shade above, and that just means anything above this function or this inequality is a solution. Now we did graph 2 of them. Before we just graphed 1, here we graphed 2 of them. So anything in this region right here where you see the blue and the pink, that's why I suggest use different colors so you can really see it. Anything you see there is a solution. So, like before, the previous lesson, you guys can have a lot of different answers. Okay? It's alright if they don't match mine. Now, I'm going to pick 8, 1. That works. Alright? You could pick 8, 2, 10, 2, whatever. I'm also going to pick 4, 2. 4, 2. So anything in this double shaded region, that means it's true for both equations, always, because remember you shade where it's true. So right here, it's true for both equations, so I'm just going to circle there. Anything there is a solution, okay? So I'm going to write, like, solutions. So anything in that region works. Doesn't matter what you pick as long as you pick something, okay? Now this next one, we're going to make it a little bit tricky. We got a word problem. Alright, I know it kind of goes off. That's okay. I'm going to break it down. My camera's being a little bit fussy right now. But example 2. So a doctor allows 15 minutes for routine office visits. Alright, so 15 minutes routine office visits. 45 minutes for full physicals. The doctor must complete 4 physicals per day and cannot complete more than 5 office visits. The doctor has 6 available hours for appointments each day. Let X represent the number of office visits and Y represent the number of physicals. Okay, and as you notice, I highlighted as I went. That's just to keep myself in check so I know what's going on. And one thing to note is when I look at this, my office visits and my physical visits are in minutes. But like he only has 6 hours. So I need to convert hours into minutes. And we have 6 hours. Let me use a different color. Let's use this one. So we have 6 hours. 6 hours. And we're going to multiply it by 60 minutes. Because remember, in 1 minute is, in 1 hour, there's 60 minutes. So when we do this, your hours are actually going to cancel. And I'm left with minutes. So 6 times 60 is 360 minutes. Okay, not that bad. Now it says write an inequality that represents the 5 constraints. Well, there's a lot of constraints to this. So let's just start with the last sentence that says let X represent the number of office visits. So X. And then we're going to say Y is the number of physicals. Okay. And let's just say that we're going to use this 360 minutes. So I'm going to say less than or equal to 360 because he can't go over. They said that. He can't go over. Now, the X, again, represents office minutes. And office minutes are 15 minutes apiece. And physicals are 45 minutes. Now, this is all in minutes, so we can leave it like that. Technically, you guys will have to use an absolute value because time can't be negative. Honestly, I'm not going to give you one like that for an assessment. So that's just like technically I need that. And then to graph this, I'm going to have to solve for Y. And there's 2 other equations in here, and we'll get that in just 1 second. I'd have to solve for Y. So what to do, because this is in standard form, is I'm going to subtract by 15x on both sides. 15x. So I'm going to have 45y less than or equal to negative 15x plus 360. Now I said I know I can't have negatives. That just means like I can't have negative 6 appointments in here. I can, when I'm moving it to standard form, I can have negatives. Don't worry about that. Divide by 45 for all of these. So I'm going to have, and I'm going to write it down here because I ran out of room. Y is less than or equal to negative 15 divided by 45 can be simplified to negative 1/3. X plus 360 divided by 45 gives me 8. So I'm going to graph this right away because I know I'm going to have that. And I'm going to have other ones in just a second. But I'm going to use my blue. And I'm going to say, okay, this equation is blue. So I'm going to go up 8. And then I'm going to go down 1 over 3. 1, 2, 3. Down 1 over 3. 1, 2, 3. Down 1 over 3. 1, 2, 3. Okay, I'm doing probably more than you need. But again, you know, I like to do as many as possible. Now, because it's less than or equal to, remember that it is a solid line. And I'm going to connect these dots. Like I said, if you have a word problem, they're not going to be as hard as this one. But I wanted to go over a word problem and how to set it up. Now, because it's less than, we're going to shade anything below it. And I'm going to keep it pretty simple like this because I told you guys we still have 2 more equations to write. And I'm going to use different colors so we can see it when I graph it. But if you remember, back up here, we said that for office visits, that's X. But we can't have more than 5 of them. So I'm going to say X is less than or equal to 5. Because I can't have more of them. And I'm going to use this pink for that. So I'm going to go over to X. And this is a solid line. And wherever I see a 5 right here, I'm just going to draw a solid line. And because it's, less than, I'm going to shade this way, anything less than that. So you can see we have an overlap right here, but we still have one more equation. Because for physicals, we can't have more than 4, so we're going to have y, or he has to complete 4, so I'm going to say greater than or equal to 4, because he has to do at least 4. He can do a couple more. And I'm going to pick this purple color. So at 4, I'm going to have a solid line. Okay? And it's greater than. So I'm going to shade this way. And then I'm going to box where the solution is because they all meet right here. In this area, you see the purple, you see the pink, and you see the blue. Now it says, well, what two points satisfy that? You can pick any points that you want as long as it's in that shaded region. So I'm going to pick 1, 7 and 5, 5. Okay, they both fit there. 5, 5, right there. Because the solid line is a solution. Again, it doesn't matter what points you pick. So just to recap, make sure that we're graphing these. If it's less than or equal to, it's solid. If it's just less than or greater than, it's dotted. So back to that previous lesson. And you're just going to graph one at a time. Shade. Graph the second one. Then shade. Wherever they both meet. So in this case right here, you can see it's all this. Those are the solutions. That's where it's true for both equations. Because we want it true for both, not just one. We want it true for both of the equations. So once we have them true for both of those equations, then you can pick whatever solutions that you want. Okay? Remember, your solutions may be different than someone else's just because there's a million that you can pick from.